Okay, gotten a lot of requests for this paper, so yeah, that should work. Let me put a stopper. All right. So, fundamental theorem of calculus practice problems. Every single one of these, in some way or another, is going to revolve around the fact that the integral from a to b of little f of x dx is equal to big F of b, minus big F of a. Every single one. So I'm always going to come back to this somehow in one of these problems. And I'm going to immediately make myself a liar and start number one. So number one says, we know that this integral is 3a minus 4b. So what's this one? And is this zoomed in enough? Whatever. So we know that from a to b, the integral of f of x dx is equal to this junk. But we have this plus 2. So what I'm going to do is I'm going to take this integral, I'm going to break it up into two integrals. Because remember, the integral of two things added together is the same as their two separate integrals taken. I said that wrong. Why am I filming myself? The integral of two things added, no, that's right. The integral of two things added together is the same as taking their integrals separately. Now that's added, that's not times. If it was times, we couldn't do this. If it was times, we would just pull the 2 out front and be done. So I know that this one is 3a minus 4b. Oh, cool, I'm already done that part. This one, though, I don't have it up here. Well, it's because it's the integral of 2. To do that, we just take the antiderivative, which is 2x, and evaluate it from a to b. What's a and b? I don't know. They're letters. We don't need to worry about what they are. So now all I got to do is plug in b minus a. Plug in b, then subtract plug in a. 2b minus 2a. Oh, snap. We got 3a, and we got negative 2a, that's 1a. And we got negative 4b, we got 2b, that's minus 2b. So I made myself a liar. I didn't actually use that in the first problem, but we will be using that in many of the problems to come. So let's see, next. All right, here's the graph of f. It says from 3 to 5, the integral is that. Oh yeah, integral's area. That right there, that's 7.7. How do I know? It tells me it's 7.7. And it also tells me that f prime is equal to f of x. That's just telling me that this integral right here, like that's equal to big F. So it's just making sure that we understand the notation here, that when we're saying this, we really are meaning the antiderivative of f. So it says f of 5 minus f of 0. That big F minus big F, that means 0 to 5, the integral of little f dx. Oh, rats, if only I knew, oh yeah, integral's area. Well, I know that area. That's a straight line. That's 6. It's 2 by 3. It's a rectangle. So this is just 6 plus 7.7. So it's 13.7. Onward and downward. All right. Next one. This is asking for the derivative of an integral. Remember, to do this, we just plug in the two bounds. So the first one's going to be x to the 4th square root of minus square root of x. And we just have to remember that after we do that, we also have to use chain rule. So this x to the 4th gets a 4x cubed multiplied by it. And this x gets a 1 multiplied by it. Now there's more we can do to clean up here, but this is, this is the main idea. So let's see, we got 4x cubed. Square root of x to the 4th is x squared. X cubed times x squared is x to the 5th. Here, nothing to do. Done. Okay. Bop the camera. All right, it says for question 4 and 5, if you're like me, you don't read and you missed that. Suppose f of x is a continuous function. We need that, otherwise we can't declare that it's integrable. And f is the derivative of the function f of x. So again, we're just making sure that we're defining and saying, hey, yeah, big F is the integral of little f is the derivative of big F. They're related. So if we go through this, it says, what's the integral from 1 to 3 of little f? And this is where big idea comes in. That integral is equal to big F of b minus big F of a. This is equal to big F of 3 minus big F of 1. So let's see, big F of 3 is 4. Big F of 1 is 2. 4 minus 2 is 2. So let's do this, done. So I'm going fast through this. I have a lot of filming I want to get done today. If the area under the curve f of x on 0 to 2 is equal to the area under the curve f of x on 0 to 2, that's just saying 0 to 2 f of x dx is equals the area under the curve f of x from 2 to 3. Oh, snap, from 2 to 3. Again. Then a equals, and this is where me and people who are doing it together were like, what? But it's because this relates to this table up here. So we're going to be using this table in just a minute, but remember this definition, the definition of this is just big F of 2 minus big F of 0 is equal to big F of 3 minus big F of 2. So I'll go to back to my table. Oh no, I was pointing to the table a minute ago and didn't move the paper. Go me. Thankfully, you probably have the paper in front of you. You know, I'll put a link in the description to the paper just in case you don't have it, or in case you have somehow stumbled upon this video and don't have me as your teacher. Hashtag subscribe, hashtag like, make sure to hit that bell notification. All right, let's see. Let's see, big F of 2 is a, big F of 0 is 1, looks like a negative 1, so a regular one. Big F of 3 is 4, big F of 2 is a. Now we get to this point and people go, I don't know what to do. It's just a simple equation. You know, it's the same as x minus 1 equals 4 minus x. So we typically want to get x by itself. So we'll collect them over on the same side. Those are gone. We have 2a minus 1 is equal to 4. So we'll have to add 1 and ignore the fact that there's text right here. So we get 2a is equal to 5. Divide by 2, divide by 2. A is equal to 5 halves. All right. Now, question number 6. This one has the most, I guess, non-calculus math to do in it. So we just need to be careful. It says find the critical point. Ooh, critical points. Remember, critical points means f prime is equal to 0 or undefined. So let's find f prime. If f of x is equal to this, then f prime is equal to sine of x squared minus times 2x minus sine of 3 pi over 4 times 0. Oh, that's gone. Because the derivative of 3 pi over 4, it's just a number, it's 0. All right. Sorry, I just saw what time it is, and I'm supposed to be somewhere right now. That's why I'm starting to rush a little bit. So now we want to set this equal to 0. So 2x is supposed to equal 0. Divide by 2, divide by 2, we get x is equal to 0. Remember, we're using the zero product property here, where this times this equals, it has to equal 0. So if this is 0 or this is 0, since they're being multiplied together, then we know that the whole thing will be 0. So BT dubs, 2x never undefined. It's always defined. So I don't need to pay attention to the undefined piece. As well as sine. Sine's this wavy thing. It never has any domain issues. So we know that that's always defined as well. So we know that sine of x squared is supposed to be equal to 0 as well. And so this is where we have to come in and go, okay, well when does sine equal 0? And that's going to lead us back to our unit circle, which I happen to have a copy of in my brain. But if we're thinking about our unit circle, sine's the y coordinate. When does our y coordinate equal 0? Psh, there, psh, there. Remember, cosine's the x coordinate, sine's the y coordinate. So I only have zeros here and here. So that's at 0 and pi and 2 pi and 3 pi, etc., etc., etc. But that's not what the question's asking. The question's asking when is x squared? So I'm going to make one of those numbers. And so it turns out that we really want to keep going. 3, 4, 5. Just keep traveling around the circle, adding numbers, and because we're going to have to take the square root of both of these. And then we got to figure out, okay, which ones of these fit our interval? And our interval was 0 to 2 pi. Well, let's see. Square root of 0 is 0. I mean, and these all could be plus or minus, but we're stuck from 0 to 2 pi. So the fact that they could be plus or minus is irrelevant because negatives don't matter. Square root of pi, yep, that's good. Square root of 2 pi, that's under 2. So square root of 2 pi is good. Square root of 3 pi, I think that's probably also good. Square root of 4 pi, and you may even want to go in and check with your calculator. 2 square root pi, that's still going to be smaller than 2 pi on its own. And I actually don't know where this stops. We would need to go into our calculator and check, which I'm going to be lazy and not do right now. But that's how we would find our critical points. I am going to go ahead and assume that Mr. Canfield maybe overstepped his bounds a little bit when he decided to have that x squared in there. But yeah, feel free to ask me questions about that on Schoology or in the comments, and I'll get back to you. Okay, I got to go, and I'll be back. Or I won't hit the button.